Welcome to ClickMyProject. Our project title is a time-efficient approach for detecting errors in big sensor data on cloud. Our modified abstract is a big sensor data is prevalent in both industry and the scientific research application, where the data is generated with the high volume and the velocity. It is difficult to process using on the hand of database management tools or traditional data processing application. The cloud computing providing a platform to supporting the address of these challenges, as it's providing a flexible stacks of massive computing, storage and the software services in the scalable manner at low cost. Some techniques have been developed in the recent years for processing the sensor data on cloud, such as a sensor cloud. However, this technique does not provide the efficient support on faster detection and the location of the errors in the big sensor data. For the faster data error detection in the big sensor data set, in this paper we are developing a novel method and data error detection approach which exploit the full computations potential of cloud platform and the network features of WSN. And first, a set of sensor data error types are classified and defined. Based on the classification, the network features of the cluster WSN is introduced and analyzed to supporting the fast error detection and the location. Especially in our proposed approach, the error detection is based on the scale-free network topology, and most of the detection operation can be conducted in limited temporal or spatial data blocks instead of whole big data set. Hence, the detection and the location process can be dramatically accelerated. Furthermore, the detection and the location task can be distributed to the cloud platform to fully exploit the computational power and the massive storage. Through the experiment on our cloud computing platform of uCloud, it is demonstrated that our proposed approaches can significantly reducing the time for error detection and the location in the big sensor data generated by the large scale sensor network with acceptable error detection accuracy. In our data flow diagram, first of all, we uploading the data set. We are selecting the data set related to our process which containing the source, destinations, packet transferring type of data set, and first of all we are applying the pre-processing techniques to remove the unwanted data and the missing values in the data set. From that we getting the error-free data set. Then we forming the error type which are all forming in the data set. In our process we are using the 4 different type of error type formation. The first one is flatline, and the second one is out of bound false, and third one is data loss, and the fourth one is a spike fault. This type of errors are defined, and finally the defined error types are applying for the process in the data set. From that we finding the errors appear in the data set which is relevant to our error type formation. Then we splitting the data set into the type of error which are defined in our error type formation. Then we find out in the result with the error. From that result we showing the different type of error with their result. The use of the error type formation is to reducing the time, and we predefine the type of error which are all occurred in the data set. Let's start our demo. Our project title is a time efficient approach for detecting the errors in the big sensor data on cloud. First clicking the start button. Okay. First of all, we are reading the data. The data set containing the source packet, destination packets, logging, and the type of protocol, data type. These are all the content present in the data set. The data set containing the 5000 record. Click next button. Here first we are uploading the data. Then we pre-processing completed. Then we loaded the data set into the database, then click the view button to view the data. The first one is the prototype, it's a TCP or UDP type, and the services HTTP, SMTP, and a flag. Totally 22 fields are 22 attributes are present in the data set. The source byte is the byte which is transferred from the source to destination, and this is the destination packet, the source packet transferring and the destination packet receiving. Then logged, this the count representing the total number of bytes transferred from total number of times the bytes transfer from source to destination. These are all the attributes. Click next button. Here we are going to forming the error type. The error type one is a flatline error, and the second one is a out of data bounds false. Then third one is a data loss fault, and fourth one is spike faults. So these are all the 4 types we are going to find in our data set. Okay, then clicking the next button. Then actually we are going to find out in the error type 1, flatline errors. Okay, here we getting the content which containing the both the TCP and the UDP with the source byte and the total number of counts the data is transferred from the source byte to the destination byte. For in a TCP, here we find out in the for a TCP we find out in which source bytes are transferring at least, and they are not transfer the data frequently to the destinations. These type of errors are called as flatline errors. That means the data does not transfer to the destination for a long time. This we indicating as a flatline errors. These type of errors for UDP also we finding TCP also we finding the least source packet transfer, and the UDP also we find out in the least source packet transfer. Then okay, these type of errors are called the flatline errors. And next we are going to find out in the data loss fault. Here total number of request different IPs is 5000. We already mentioned the dataset containing the total number of records is 5000. Okay, then we find out in the source error packets. These are all the data loss faults are the source transferring the data, but the destination does not reaching the packet or it containing any error in an intermediate processor. The source byte sending the packets, but the destination bytes does not receiving any packets from the source. These are all errors are called data loss fault. Okay, here we find out in the total 5000. Here 183 records are does not having the destinations reach their destination. Okay, their average error value is 3.66. Here we are using the formula to find out in the average error value. Next, the spike faults. The spike faults, here the total number of request count apart from the 5000 we eliminated 183 and the balance is 4827 requesters. Here we going to find it in the spike faults. The spike faults is nothing but it is unpredictable and it may be occur. This type of errors are we define here, and in balance 4817 data records. Here 1485 data are error data. We getting the information which are all containing the error data. The 1485. These are the spike faults. Here we mentioning the what type of error, what is the data byte, what is source count, source byte error and the count. The graph representing that the existing system and the proposed system. The existing system, our the accuracy of result level value is low. For in the proposed system, we are defining the error type in a predefined, so find outing the errors very accurately comparing to the existing system. Okay. Thank you.